All right, so on this slide we see many different sources of water pollution. Most of your water pollution does come from non-point sources, from runoff and seepage and infiltration, primarily from runoff. Infiltration, soaking down the ground, usually a good thing. It will take care of your nutrient pollution as the bacteria decomposes or gets absorbed by the rocks and things. But really bad stuff, toxic materials like your heavy metals and your organic petroleum type pollutants and things like that can go through if it infiltrates and can get it out in the groundwater. So that's an issue. That's also non-point. If it soaks down, it becomes a water pollution problem there. But most of it is runoff. You do get some point source pollution. From the main source of that is your treated wastewater. As we said, most wastewater is treated to a secondary level in developed nations, like the United States. And that takes care of all the bacteria and the organic stuff, but it still leaves behind phosphates, nitrates, etc. Put that on the side, please. And which, of course, are going to be a source of algae blooms and eutrophication, cultural eutrophication. Spills and leaks and things like that, if you can pinpoint it, that makes it point source pollution. But those are also, of course, a source of water pollutants. One of the things, of course, to keep in mind is that with the water cycle and the fact that water is a good solvent and it's going to run down into your groundwater and surface water, that's why any contaminant, any pollutant that's out in the environment has the potential to become water pollutant, get into the water. We spend quite a bit of time on cultural eutrophication. That is the biggest environmental problem that is associated with water pollution. So you need to know the details of it, the nutrient input, inorganic nutrient input, algae blooms, sunlight penetration is decreased and therefore water clarity decreased, therefore it kills the plants on the bottom. Dead plants decompose, oxygen levels drop, that kills the fish, etc. And you just get this worse and worse scenario happening. Biodiversity decreases excessively because of, mainly because of the drop in oxygen levels that comes from that. Any questions about that? Okay. Now, one of the things that we didn't really go into a whole lot of detail about is the nitrates versus phosphates. So you hear nitrates and phosphates over and over. Those are your two main ones. However, you should know that the nitrates, chemically speaking, are very soluble compounds. And so if you've got any source of nitrates around, you're typically going to have fairly high nitrate levels in the water. And it's not unusual to find not high nitrate levels in water that is naturally eutrophic. As you remember, that we call it cultural eutrophication because eutrophication itself is a natural process. You guys need to be off your phones, please. Pay attention. So nitrates are usually, there's enough of it for algae growth, but they need phosphates as well. And phosphates usually are not very soluble. And you may remember that we talked about the phosphorus cycle. That's one of the properties of phosphorus compounds is that they don't tend to form gases and they don't tend to dissolve very well. However, people, of course, come in and mess things up. So, rewind a little bit. The fact that they usually are not soluble makes them a lot of times the limiting factor. And in order for cultural eutrophication to take place, you need to have the free-floating planktonic algae. Those grow excessively, which means you need to have dissolved nutrients in the water. So if those phosphate levels in the water, dissolved phosphate levels in the water are not high, then you're not going to have a lot of algae. That's what makes the limiting factor. It's got plenty of nitrates, but not much algae. It's like if you've got 1,000 jars of peanut butter, but only one jar of jelly, then you're only going to be able to make that one jar of jelly's worth of sandwiches. Although I would eat it without the jelly. So, like I said, people, of course, never satisfied. We mess things up in that we produce types of phosphates that are not usually naturally occurring. They're out there in nature, but not that much. But we produce and manufacture things like superphosphate. There's another couple of orthorhombic phosphates, another type that is actually pretty soluble, much more soluble than most of your types of phosphate. And we do that because we want it to dissolve easily so the plants can absorb it. That's the main reason. And in the past, we used to include these in detergents. So what happens, of course, we still put it on fields and stuff because we don't have the plants have got to have phosphorus. So we don't have a substitute for that. But with detergents, they have removed it in the United States in the 1970s. They passed legislation to remove it because what was happening was that these phosphates in the detergents then, of course, would end up being phosphates that were coming out of your secondary wastewater treatment plants, and they figured out that it was a soluble phosphate that was the problem that was causing a lot of cultural eutrophication, particularly in these bodies of water that you have secondary wastewater being discharged into, which was a lot of places around, all around, developed nations in particular. So by eliminating that, they have reduced a lot of the problems associated with wastewater discharge. But understand that the phosphates, first of all, that the nitrates and phosphates, the main things the algae feed on, and that they need soluble phosphate to really take off. And a lot of times in a natural setting, they wouldn't have that. So that limits them. That's a limiting factor. So remember that particular that idea. And then the fact that people, of course, have come in and used soluble phosphates both for fertilizer, which we still do, and in the past, and I would imagine in other parts of the world they still have phosphates in detergents. But in the past we've used phosphates. Of course, you want to have something that dissolves in your laundry and stuff like that. So it's a soluble form of phosphate, and that ended up going out into once it went through the sewage treatment process and getting discharged into bodies of water and causing lots of cultural eutrophication. So that's actually been more of a culprit in some areas than your runoff from farms. Because remember, farm runoff is unintentional. Farmers actually want there to be, for that water to soak down in the ground, not to run off. And not only that, it causes erosion, things like that. Wastewater has to go out into, it's a point source of pollution. They're intentionally putting that out in the water. So it needs to be done, something needs to be done to make sure that that's as nutrient-free as possible. And this is one of the steps that's been done to do that. Questions about that? Phosphates versus nitrates, phosphates in how they've been in detergents, and that's been a role in the past? No? Okay. So you can look at that again. That was from that video we watched on St. John's River. It's a good one on eutrophication. Now, untreated wastewater, raw sewage. You do have some human raw sewage in some areas, developing nation worlds. I believe this is in Venezuela, where it's still being pumped directly in, or you just don't even have it at this level. You have villages and stuff that are dry riversides, and they naturally drain into there. That's going to be a nutrient problem, but also, of course, it's going to be a big problem with disease. And we see this. It's one of the leading causes of death worldwide are these waterborne illnesses from untreated wastewater and facilities, and the inability to treat the water itself for drinking purposes. So this is what we see, and those are some of the health problems associated with it. Now, in the developed world, we have this organic waste going in, typically from your feedlots and livestock and things like that, as you can see here, because we have those things. We have a lot of farming operations, whether it's cows or hogs or chickens. Actually, chicken waste is very high in phosphorus, so that's a problem. So that's a kind of a contrast between what you have in developing versus developed nations, both of which you have organic waste input, particularly human or animal waste. So here's our flowing stream situation. Look closely, make sure you understand this diagram, because this shows us this dissolved oxygen versus biological oxygen demand. So you want to make sure you understand what both of these things mean and why they are inversely related to each other. As one goes up, the other goes down. So as I mentioned before, your biological oxygen demand is just basically the amount of organic waste that's in the water. Because what it is, literally, is how much oxygen it will take to break down the organic waste that's in the water. So more waste requires more oxygen, means a higher level of BOD, biological oxygen demand. So you got this flowing river. Before you have this input of organic waste, maybe it's coming from an animal farm, maybe it's raw sewage. You've got a nice healthy stream with indicator organisms, fish and other types of things like stonefly, mayfly larvae that need high oxygen levels, and they can survive in there. Everything's good. You get this organic waste comes in. It's indicated by the red line here, jumps up here. Bacteria start to eat it. As they are eating this waste, they are consuming oxygen to do that. That's what you use oxygen for, is to break down your food, so do bacteria. So the dissolved oxygen is going to drop as well, and you're going to get into this zone where it has very low levels of oxygen and low levels of biodiversity. You have organisms in here that can tolerate those low oxygen levels. Now, I will say this, that is not illustrated here. These organisms are still present over here, but now in this area their population numbers will go up because they don't have the competition from the other ones that needed the high levels of oxygen. So it's just another illustration of how overall amount of living material, amount of what we call productivity, does not actually decrease in these nutrient pollution problems, but the biodiversity decreases. So you're not going to have a lot of these things. You'll have some of these that can tolerate it. And then being a river and everything, it does have the chance to recover. So that's what we call recovery zones. So eventually the bacteria is going to eat up all that organic waste. If you don't have any more coming in, then the dissolved oxygen levels will start to return, of course, because it's flowing water, that'll help to aerate it as well. So you need to be familiar with the effects of organic waste going into a flowing water or river type ecosystem, and that is illustrated here, and I put it down there in text in a more detailed spot there. So understand that, understand the difference between that and a cultural eutrophication scenario. Notice here, no algae in this one. Just goes straight to bacteria. All right, then you have a lot of, just to kind of put all together some of your different industrial type water pollution things. These are not nutrient pollution per se. These are things like like I said, notice a lot of these are going down into the aquifer. Nutrient pollution is not going to really affect the aquifer too much. You do have sometimes nitrates that can get down in the water if you use a lot of nitrates in your fertilizer. They can sometimes get in the water, and high nitrate levels have some physiological, like blue baby syndrome. There's certain physiological conditions from that. But otherwise, PCBs, benzene, toxic waste from landfills. This is why you don't want to throw certain things away in the landfill, because the rainwater will take it down through and soak it down the ground. We'll talk about acid rain later, but this also tends to, because it dissolves metals and other things better, tends to carry these pollutants also into the thing there. Leaking gas tanks, big source of gasoline and diesel tanks. When you go to Wawa and fill up, there are storage tanks underground that have the gasoline in it. Now, you know, like many things, they are better controlled, and they monitor the groundwater around it. They test it on a regular basis. In the past, you've had a lot of examples of people's drinking water supply contaminated by gasoline and diesel tanks and stuff like that. Wastewater treatment, etc. In this case, they're talking about chlorine and fluorine that can get into the water supply, and also copper and lead pipes. So this is your Flint, Michigan scenario here with the lead pipes and everything, because actually what happened was the water acidity increased because of the treatment they had to do to it, because they're using the Flint water, the Detroit River, which was notoriously polluted, and they had to treat a lot to do that, but that treatment made the water more acidic, and therefore that acidic water going through these old pipes that have been around for a while. Lead was a common type of pipe to be used in the early part of the 20th century. That increased acidity dissolved the lead more, and that's why it became a problem. Whereas before that, they still were going through lead pipes, but because the water pH was higher on their former supply, they didn't have these problems. Okay. And then warm water, thermal water pollution, common from power plants, etc. That's a common type of. You guys see what's down in here?
Manatees.
Yeah, manatees. They love it. So it's good for them because they need to escape the cold a lot of times. But warmer water, thermal pollution can cause lower oxygen levels. Oxygen doesn't dissolve as well in warm water, and it can increase algae and bacteria blooms and things like that. And fracking can introduce contaminants into groundwater supplies from there. Okay. Mining. We talked about how mining tends to produce acid mine drainage, and chemicals and metals are exposed at the surface, and those will end up in your water supply. So that's a source of water pollution. So now, granted, I went into a lot of detail on the wastewater treatment plant here, but the main things you need to remember is with primary, it's basically allowing stuff to settle out, as well as allowing the natural bacteria that's in human waste to digest the organics in there, and then eventually that will overflow, or if you have like a septic system, it'll drain out through a drain field. But a lot of, if it goes to wastewater treatment plant as secondary, they add to that. From there, it goes into a aeration system where aerobic bacteria increase the rate of digestion of organic waste. So that's important to know that that's a defining characteristic of secondary wastewater treatment. And if these things are to be discharged above ground and exposed, you gotta disinfect it. So they may use chlorine, may use UV light, or ozone. They didn't put ozone in there, but I think I listed it down here somewhere. Yeah, chlorine, ozone, or UV radiation. And then if you have tertiary treatment, there's a number of different ways in which you can, either chemically, physically, or biologically, through putting it through wetlands and stuff, remove the nutrients before discharge into a natural body of water. So that's ideal, of course. One of the things I didn't talk about too much, but you need to be aware of, is that during this process, you do have a buildup of solid bacterial waste called sludge, and these have to be disposed of. A lot of times it's sold as fertilizer, but it is a waste product that comes from there. That can be an environmental issue if it's not disposed of properly. In this case, sometimes they'll take that sludge, by the way, and recycle it through the aerator tank, and the bacteria will eat it up and decompose it some more, so there's less of it there. But that's what the sludge part is. If you have a septic tank at home, you have to get that's what septic contractors do. They come out and pump the sludge out of your tank. So make sure you watch that video also. Some of the problems one of the main ways to reduce the problems from water pollution, from runoff water pollution, is to redirect that pollution into retention ponds, wetland areas. As that water, you can see this diagram here, as it goes in, water can evaporate, it can soak down in the ground, so you're basically reducing the amount. That's what the little arrow indicates here. And they typically are in a chain, in a line, so this will fill up. You'll see this kind of like drain grate, and it'll overflow that and go into your next holding pond, retention area. Ideally, you'll have something that's like a wetland area, because that'll absorb the nutrients too, and eventually by the time the water finally makes it into a natural body of water, both the volume of it has decreased, as well as the nutrients and other things that were in it, and the sediments and those kind of things have settled out or been absorbed by the plants and stuff, and therefore the end effluent that ends up going into natural body of water is lower in volume, lower in plant nutrients and sediments and all that other stuff that you don't want going in there. So that's a typical way to deal with water pollution problems, and that is the end of that presentation. So any questions about that? This is an example of what can happen from ocean garbage type pollution. I want to show you, make sure you see here.
All of this is just more proof that nature seeks balance. Like if you have too much nutrients, you're going to make algae, and that's going to deplete oxygen. You have not enough, nothing that can survive.
True. Yeah, you're absolutely right. Actually, nutrients are usually good for an ecosystem, but of course it's the human part of it that messes things up. So here's our test. Notice on there, you guys make sure you see this, water test. This is, I should probably rename a water test table. So we've got 18 different water tests that you need to familiarize yourself with, both the name of it, what it tests for, which is usually pretty obvious, it says it right there, and more, and also what kind of impact these different things have on the ecosystem. Okay, so you'll get a matching question, probably about 12 to 15 points on that one related to that. So make sure you study that, okay? Everybody clear? That's it.